Hello viewers, welcome back to class. I'm super excited to welcome you all back to Master Builders Online Academy to continue our series of lessons. If you are new in this channel, do consider subscribing to our channel and ensure that you turn on the post notification bell for more exciting videos. Now guys, do not forget our policy. Anytime you are set to watch and to learn new concepts from our platform, do not skip any part of the video and ensure you avoid every unnecessary distraction. Gain maximum attention and focus before you start watching and learning from our platform. And finally, if there be any part in this video you do not understand, when you watch it for the very first time, guys, you have a very singular opportunity to replay the video over and over again until you understand this. And that's the reason why this lesson is coming in video format. But if at the end of watching this video over and over again, you still do not understand some concepts, guys, do not hesitate at all. You can quickly dive to the comment section and state every question that you have. We will kindly answer all your questions, give you profitable answers, and you will smile and rejoice. So guys, without wasting much of our time and for interest today, let's get to work. On the board we have computation of limit. Of course, we are still looking at computation of limit. This is part 4. And now we have problems on the board. We are asked to find the limit of the following. This is a very special case of limits. But like I said earlier, no matter how special it is, there are two factors that controls limit of functions. One is whether the function is linear or quotient. If it is linear, you don't have issues. All you need to do is to substitute the given value and you are done. But when it is quotient, you don't just substitute, you test run with the denominator and see whether it is defined or undefined. And it is said to be defined when the denominator, the value you obtain at the denominator, is not 0 or is a real value. But when the value is 0, then you have undefined. Now on the board we have 4 more questions to look at. And all of these questions that we have here, they are all quotient functions as identified, right? As we have them on the board, they are all quotient functions. So what must be done to quotient functions? Denominator is my area of concentration. That's all. Now let's take the very first question. We have the limit of x tends to a. And we have x squared minus a plus 1x plus a all over x cubed minus a cubed. Alright, this is the first question that we have. All we just need to do here is to look at the limit that we are given. We are told that we are given that x is equal to a. That means this function is a function of x. A is a constant. Because here we have 2 variables. So you need to understand it via this condition here. X is equal to a. That means x is the function, while a is a constant. It can be assumed to be 4, 5, any integer. Are you there? Now, if this is understood, all I need to do now is to just come to the denominator and pull down the denominator, which we have as s cubed minus a cubed. Now, if I substitute a, we know that x is equal to a. So when I substitute a here, I'm going to have a cubed minus a cubed. And a cubed minus a cubed is 0. Now that I have 0 at the denominator, what will I do? I need to factorize this to ensure that I cancel out any of the factors at the numerator that correspond to the one at the denominator. But in this case, it will not be easy for us to do that way. All we just quickly need to do, based on the fact that we are attending to objective students and we are using only L hospital rule, we are quickly going to make use of L hospital rule. And in using L hospital rule, we need to differentiate each of these functions individually. That's all. So when I differentiate s squared, I have 2x. Now understand that a plus 1x. A plus 1 is a coefficient of x. This can be assumed as 3x. And you understand that when you differentiate 3x, you have 3. Only the coefficient is left. So when I differentiate a plus 1 or multiply by s with respect to x, s disappears. Then I have minus a plus 1. When I differentiate a, being a constant with respect to x, I have 0. Then I can ignore that. All over. At the denominator, when I differentiate s cubed with respect to x, I have 3x raised to the power of 2. And when I differentiate a cubed with respect to x, I have 0 because it is a constant if I differentiate a with respect to x. Now finally, all I need to do is to substitute a at the denominator, and if I do that, I'm going to have the value at the denominator exist. Therefore, this will be our final bus stop. All we need to do here is to substitute the value of a. I have 2 multiplied by a, which is 2a, negative minus 1 multiplied by a, we have negative a, and minus 1 multiplied by positive 1, we have negative 1. All over 3a raised to power 2. We just replace x with a. Then finally, all we need to do is at the numerator we can remove a from 2a, and that would have given us just a. So we have this as a minus 1 all over 3a squared. This is the answer to this very question. Now, let's look at question number 2 very quickly. We have the limit of h tends to 0, and the function there is pi open bracket r plus h all squared minus pi r over h. Pi r squared over h. Now, all I need to do is to look at the denominator. Now, at the denominator, I have h. And we said that the value of h is equal to 0. So that means if I substitute the value of h directly to this equation, I'm going to have an undefined function. And what do I do now? All I need to do is to use a L'Hospital here. And now we are differentiating this function with respect to x. Are we there? Now that we have h here, we are not going to differentiate with respect to x. We are going to be differentiating with respect to h because this function is a function of h as defined here. H tends to 0. That is to say, r is a constant if this function is a function of h. And equally, we know that pi is constant. It's a constant value. All right. Now, all we need to do here is to what? Differentiate, having ascertained that if we impute the value of h at the denominator, we will have an undefined expression. So we substitute the value of h. And when we do that, we will quickly differentiate this function using L'Hospital. If I differentiate this first function, now look at what will happen here. H, I have h inside this bracket, and this happens to be what? Chain rule. So if you understand when we're differentiating chain rule, where we have 3x plus 4 all raised to the power of 5. You know how we used to differentiate this. Bring down the power, reduce the power by 1, and differentiate what you have inside the bracket. This is how we used to do it. So first, if I differentiate r plus h with respect to h, I will have 1, and that does not change the value. So when we differentiate this, we are going to have 2 multiplied by 1 multiplied by pi into r plus h. We will now reduce the power by 1, and that would have given us 1 here. Then when we differentiate pi r squared with respect to h, this is a constant, we have 0. Then we ignore that. All over. When we differentiate h with respect to h, we have 1. And this would have given us 2 pi open bracket r plus h. Now at this point, I do not have a denominator. Now I can substitute for h, and whatever I have, now that there is no denominator, becomes my answer. And if I impute the value of h, which happens to be 0, we will have had this as 2 pi r plus 0. And now when we add 0 to r, this would have given us 2 pi r. This is the answer of this question. And this becomes the perimeter of a cycle. Perimeter of a cycle. So this is how it is. The first thing you do is to look at the denominator very closely. When you do that, if you the given value, when it turns out to be 0, you must use L'Hospital rule to what? Solve the problem. So very quickly, let's look at question number 3. We have limit of x tends to 0, sine 5x over sine 2x. Now, in the same vein, we have a numerator here. We equally have a denominator. Principles are what matters. At the denominator, I have sine 2x, and that is my major cosine. I must ensure that the denominator is not 0. So if I impute 0 here in place of x, I will have 2 multiplied by 0, which will give us 0, and automatically this gives us sine 0. And when you check this out with your calculator, sine 0 is 0. That is to say, if we impute this value directly to this function, we are going to have undefined expression. Even at the numerator and the denominator, we have 0, which makes this undefined. Now, what must we do to make this function a defined function? We need to use L'Hospital rule or factorization. Of course, we cannot factorize this strict function. We can only use L'Hospital or any other method. Now, let's use L'Hospital. How do we use L'Hospital here? All I need to do here is to differentiate the function at the numerator and equally differentiate the function at the denominator. Now, I taught us in one of our lessons that if I differentiate sine ax is equivalent to a cos ax. So if you remember this when we were dealing with standard derivative, when we are dealing with standard derivative, then we don't have issues with it. So when I differentiate 5 sine 5x, I will have 5 cos 5x. And equally, if I differentiate sine 2x, I will have 2 cos 2x. Now I will substitute x. Having differentiated once, I need to now impute the value of x and see whether the denominator will still give me 0. If it does, I need to differentiate again, still using L'Hospital rule, and that becomes the second derivative. Now, this will have given us 2 cos 2x, and x is 0, so 2 multiplied by 0 is 0. And I understand that cos 0 is 1, and 2 multiplied by 1 is 2. That means the denominator now exists. And as now that the denominator exists, all we need to do is to substitute the values direct. Our interest is that the denominator must not be 0. It can be any other value, but not 0. So here we have 5 cos 5 multiplied by 0, which is the value of x, we have 0. Degrees. 2 cos 2 multiplied by x, which is 0, is 0. And we know that cos 0 is 1. So this will have given us 5 multiplied by 1 and 2 multiplied by 1. Then the final answer to this would have given us 5 over 2, which is simple as 2 whole number 1 over 2. Or you can have your answer in decimals as 2.5. That's it. So this is how you work this out. Now listen to me, let me quickly give you the shortcut of having this done. When you have a sign of a function at the numerator and you equally have a sign of a function at the denominator, the answer is just their coefficient, 5 over 2. Pick the coefficient of x at the numerator and pick the coefficient of x at the denominator. That solves it. When you have sign of a number here and have another sign here, the coefficient of the angle is what makes up your final answer. Now finally, let's look at question number 4. We have that the limit of x tends to 0 into 1 minus sine 2x all over x raised to the power of 4. When we look at this function, guys, we find out that this function in itself is a quotient function. We have a numerator and we have a denominator. So, by the principles, we know that our focus is on the denominator. And what function do we have at the denominator? The function at the denominator is x raised to the power 4. And the value of x is 0. So if I have 0 raised to the power 4, I still have it to be 0. This is undefined. What must I do? I need to differentiate. This is how it goes. So guys, if you have not subscribed to this YouTube channel, do consider subscribing to this YouTube channel and ensure you turn on the post notification bell so that you will not miss out from good content, amazing content like this. To maximize all that good content that we have in stock for you, you need to turn on the post notification bell so that you will be notified anytime we release mind-blowing content like this. Okay, now when we differentiate this using L hospital rule. And now, how do we do that? When we differentiate 1, we have 0. We ignore it. But when we differentiate sine 2x, just the same way we did here, we have this to be what? Negative 2 cos 2x all over. When we differentiate the denominator, we have 4x cubed. This is what we have. We have 4x cubed. Now, if I substitute 0 here, it will be 4 multiplied by 0, and 4 multiplied by 0 is 0. That means I need to differentiate this again. Now, I will differentiate this the second time, minus 2. Now, if I differentiate cos x, I have negative sine x. Now, the same way, if I differentiate cos 2x, I will have negative 2 sine 2x. So now, these two will have to multiply this as multiplied by negative 2 sine 2x all over. When I differentiate this, we will have 3 multiplied by 4, and this is 12x squared. Now, at this point, when we simplify this out, this will have given us 4 sine 2x over 12x squared. At this point now, when I check the denominator, don't forget, the denominator is our focus. If I impute 0 here at the denominator, I will still have this as 0. That means I need to differentiate this function until s at the denominator is no longer there. I have constant at the denominator. So what must I do again? I need to differentiate this. And as I differentiate these 2 here, we multiply this 4. And we have this as positive 8. When I differentiate sine 2x here, I have cos 2x all over. When I differentiate 12x squared, 2 multiplied by 12 will give us 24. X, I reduce the power by 1. Now, at this point, let's substitute the value of x. This will be 24 multiplied by 0. And 24 multiplied by 0 will equally give us 0. And we do not want 0 at the denominator. Then we need to differentiate this again. Now, if we differentiate this result again, we will have this as negative theta. Now, listen carefully. If I differentiate cos theta, I know I have negative sine theta. So, I know that my answer will turn out to be negative. Put down the negative sign. Now, 2 multiplied by 8 is 16. Put down 16. Then I have sine 2x all over. When I differentiate 24x, I have just 24. So at this point, I have successfully reduced the denominator to a constant where I do no longer have x. Now, at this point, this expression or function exists. I can impute the value of x. Now that I do not have 0 at the denominator, I can impute the value of x. And when I do that, we will have this as negative 16 sine 2 multiplied by 0 would have given us sine 0 all over 24. And we understand that sine 0 is 0. And 0 multiplied by negative 16 is 0. Then this will have given us 0 over 24. And 24 divided by 0 is 0. So the answer to this question is 0. Yes, it is very, very possible for you to have 0 in limits, but not at the denominator. Your final answer can be 0, but you do not have 0 at the denominator. But you can have it at the numerator. This is it. So guys, we are getting closer to the end of this lesson. The most important aspect we are going to quickly look at now is the limit of quotient function, where the limit value tends to infinity, and that we will look at in a short while. So guys, don't forget to subscribe to this YouTube channel if you have not done so, and ensure you turn on the post notification bell for exciting videos. See you guys in the next class. Guys, you can quickly check the description below where you will find the link to the next lesson. Love you guys. See you.